Okay, so a big goal of this chapter is to get you to visualize what's actually happening in reactions that we write down on a piece of paper. So we're going to write pictures of what happened during our explosion lab, what happened in the oxygen generator cylinder, the hydrogen generator cylinder, and the explosion itself. So the first thing we had to do was make oxygen. So we took peroxide, and I want you to draw what you see me drawing here. We took peroxide in a cylinder, which was hydrogen with 2 oxygens and a hydrogen. These are all bonded together, so they should all be touching. Okay, this is what peroxide looks like. And it fell apart, it decomposed, and we used potassium iodide as a catalyst, that white crystal. And we draw catalysts above the arrow because they aren't really involved in the reaction. So, I'm going to put an arrow in my picture. What happened was, it created oxygen and water. Now, in my cylinder, the oxygen was bubbling out. There's my particle picture that was coming out. It's a gas. This is a liquid, and my expectation is that you write down everything you see me writing down. And what was left behind was water. Oh, I want to make this as a particle picture too. Okay, but this is definitely not balanced, and today we learned that we write reactions in a balanced form where we're the same amount of reactants as products. And right now we have 2 oxygens. There's no way that can make 3 oxygens. So that means we probably needed another peroxide in this reaction. So we're going to put a 2 in front, which means there's 2 that are not bonded together. They're separate, but they're both kind of in this, making up this clear liquid. So from this clear liquid, which is peroxide, 2 peroxides probably decomposed. This one is called decomposition. It's when one compound falls apart into smaller ones. So that probably, now I have 4 oxygens, so, and now I have 4 hydrogens, so I could probably make another water over here. This doesn't really fit in my cylinder. Make yours fit in the cylinder if you can. But we probably made 2 waters. And let's see, oxygens 1, 2, 3, 4, 1, 2, 3, 4. One is making 1 oxygen molecule and the other 2 are in the water. So I've drawn kind of a picture that this is, you know, in the clear liquid and this is coming out. And make sure that you have these symbols that tell you that this is a liquid, this is a gas, and this is again another clear liquid. So that's just an example. You'll do the part, start the other ones for you and you'll finish them. So what happened in the hydrogen generator? Well, we started out with a strip of magnesium. I'm just gonna write Mg and we're gonna put an S here for solid. And in my graduated cylinder, I had a clear liquid, but this was aqueous because we had something dissolved in it. HCl was dissolved in it. So H plus, Cl minus. These are separated because they're really dissolved. And what happened? Well, when we put the magnesium into this solution, what you should have seen was the magnesium eventually disappeared and what was created was a gas. And the gas was not yellow, so we know it's hydrogen, and hydrogen we know is diatomic. So I had a little hydrogen coming out. And again, I'm gonna put a G here for gas. And the magnesium hooked onto the chlorine, and in lab we actually calculated that for every 2 chlorines there was 1 magnesium, and this makes sense because this is really aqueous, it's really dissolved. We didn't actually see the white crystals, right? It was still in this clear liquid, but what we had was Mg plus 2, Cl minus 1, Cl minus 1. We had these floating around inside the water. Well, this isn't quite balanced because here I have 1 hydrogen and here I have 2. Here I have 1 chlorine, here I have 2. So that means we probably started out not with 1 of these and 1 of these, but 1 of these and 2 of these. So I'm going to draw in my picture another hydrogen plus and another Cl minus floating around. And now it's balanced. I have 1 magnesium, and this is called single replacement, which means, and you'll be asked to kind of classify reactions eventually. The magnesium replaced the hydrogen. right? We see that the magnesium was now in the place of the hydrogen. So this is called single replacement. Now the explosion was another type of reaction. It was hydrogen plus oxygen, and we know that these gases are always diatomic, and we'll put G's for gases. And they came together. We needed a flame, so a triangle actually indicates that we added heat to the reaction, and we created water. And we did this with a flame. So on this side, you know, draw the pipette, and we collected these gases from the top of these cylinders. So show that you have hydrogen and oxygen in here. And let's balance this. Oh, and this one should be like a Bunsen burner flame. You can draw a Bunsen burner, and kind of in the flame is going to be where the water is. And the water actually in this case was gaseous because we created it in a flame. Now this is not balanced. See if you can pause this and balance it. So we see we have 1 oxygen here and 2 here. So it probably means that we had enough oxygen to make 2 waters. Let's see, so in here is my, let's see, and so I've got 2 oxygens now. So you can draw your flame however you want to draw the flame. Oxygen with my hydrogens, but I've got 2 now and they're gaseous. Okay, but now I have too many hydrogens, so I probably started out with 2 of these. So in here, draw, you know, 2 hydrogens and 1 oxygen. Remember, they should be together because they're diatomic, but there's 2 hydrogens and 2 oxygens. And then we created, after we put these 3, squirted these flames into a flame, draw a better Bunsen burner than me, we created 2 waters. So a couple things we're going to learn in this unit. Oh, and by the way, this is called combination. Make sure you're writing down everything I'm writing down. So we have 2 that are coming together and combining. So decomposition and combination are sort of opposites. Here, they're falling apart. Here, 2 are coming together. And the single replacement is they're kind of switching out. So you're going to learn how to classify equations, how to balance them, and eventually we're going to learn how to predict the products.